Right, hello Year 11 triple scientists. Today we're going to look at something called the Haber process, okay? This is kind of like a process of how we make ammonia, and we'll talk about why we need ammonia in a minute. This is a Year 11 triple chemistry topic. So, just so we're, again, focusing on it being as normal lesson, recalling our prior knowledge. What I want to see on your sheet of paper, in your booklet, however you're doing it, if you're just typing it on Word, that's great, or you're just filling it in the PowerPoint, they're all fine. Can you please pause the screen now and have a go at the five questions on the screen, okay? Right, so you should have now had time to pause the screen and have a go at them. So I'm going to now go through the answers. So what's phototrophism? Phototrophism is when a plant responds to a stimuli, and that stimuli is light. Okay, so essentially, if a plant is responding to a stimuli, that stimuli is light. Gravotrophism then, exactly the same thing, a plant responding to a stimuli, and that stimuli is gravity. Okay, so a plant's response to a stimuli. What is the hormone which controls plant growth? That's auxin, or auxin. What pH would a strong acid have? So a strong acid would have a pH of 1 to 3 normally, 1 being the strongest. Sometimes you even see 0. It's not something we use massively, but you might even see 0 pH, okay? That's the strongest acid. What is the equation to work out concentration? So the equation is moles equals concentration times by volume. We're triple scientists, we're in year 11, so we need to think about rearranging that because the question says what is the equation for concentration? So the easiest way to do that is to swap it over. It's times on this side, so it's going to be divide on this side. So it would be moles divided by volume equals concentration. Remember with the volume, normally it's in centimetres cubed, so we need to divide it by 1,000 to get it into decimeters cubed, okay? These are all things that we constantly need to be thinking about when we're looking at these questions. What are the other things I need to know? So I know that question just said, what is the equation to work out concentration? But can you see the thought process I went through there? Rearranging it, looking, remembering that they normally come in centimetres cubed. So there's a couple of things to be thinking about. So, like I said, we're going to look at the Haber process today. Your keywords are ammonia, fertiliser, synthesis, which means how we make things. Make or making, hydrogen and nitrogen. So nod of words, your learning objective today, what I hope you get by the end of it, deduce the stages of the Haber process. You need to be able to tell me the stages and the conditions. So we need to be thinking about the conditions of the Haber process. So to get started, I'm just going to do a little bit of a background. What is ammonia? How do we test for ammonia? Stuff like that. So ammonia is an important raw material in making fertilisers. Okay, so fertilisers, thinking back to core biology, they are how we make or help plant growth. Okay, so that's a big thing with fertilisers. They're how we aid plant growth. Okay, some ammonia is then used to make nitric acid. So we use it to make explosives. And the other thing with ammonia, and you might even know the smell of ammonia from watching your parents, grandparents, doing some cleaning. So ammonia is quite a useful and main ingredient in a lot of cleaning fluids, okay? So without making ammonia and then putting it into fertilisers, we wouldn't be able to grow food. So it's really important that we have a manufacturer of ammonia to be able to grow food, to be able to feed the population. Okay, so that's what it says there, talking about that, feeding the population, because we need ammonia to make fertilisers. Fertilisers help plants grow better, less likely to catch diseases. Okay, so you increase the yield. So using a fertiliser tends to increase the yield and the the condition, how well they look of the plants. The other thing you need to know about ammonia, you might be asked in the exam, is how we test for ammonia. So you've got a sample of gas. Ammonia naturally exists as a gas, and you want to make sure it's not ammonia. You want to make sure it's ammonia, not oxygen, not carbon dioxide. All you have to do is get a piece of damp red litmus paper. So you can see it here. Damp red litmus paper, just little bits of paper. You use them to test pH. What it does, if the ammonia gas then gets onto the damp red litmus paper and it turns blue. Okay, so how do you test for ammonia? damp red litmus paper, and it should turn blue. Okay, sometimes they ask you, so I've added this down the bottom, sometimes they ask you how do you test for ammonium compounds, so ammonia mixed with something else, often chlorine or nitrogen or sulfur. So how do you test if ammonia is being mixed in with something else? Okay, all you have to do is heat it with sodium hydroxide, so that's NaOH, okay? Heat it with sodium hydroxide, and then you just do the damp red litmus paper test, okay? So if it's in a compound, normally in a chlorine, with a chlorine to chloride, or with nitrogen, if it's already in a compound, then you need to heat it with sodium hydroxide and then just perform the same test. If you've just got ammonia on its own, then you don't need to heat it with sodium hydroxide, you just perform the test. Moving on then, so exactly the same thing now. I've talked a lot about what ammonia is, okay, the uses of it and the test, so like a background to ammonia. What I want you to do now is press pause, okay, and have a go at answering these questions. Okay, answering a full sentence is really important to practice that skill, okay, really good literacy, and it shows the examiner you know what you're talking about, okay. Right, so give 3 uses of ammonia. So ammonia, the main use, and we talked about this, is in fertilisers to help our plants grow. Okay, it's also used an awful lot in explosives and in cleaning products. Okay, so there's 3 big uses of ammonia. Okay, there might be other uses, but they're the main uses that would be useful to remember. What is the importance of ammonia? Mainly for food growth. To ensure that the population, and the population of the world, or even just the UK population, has enough food. So, access to food. Okay, so importance, you could say something about it being cleaning products, thinking about killing germs, but the main thing is we've got to make sure that we've got enough food to feed the population. Everyone has access to food, so we've got to make sure that we can grow enough food. How do you test for ammonia gas? Like I said, ammonia is a gas. That's damp red litmus paper. Hold it over the gas and it should turn blue. How do you test for ammonia salt? So ammonia mixed with something else. You need to heat gently with NaOH, so sodium hydroxide, and then you just repeat that experiment. So once it's heated with the NaOH, ammonia gas should be given off. Okay, so that's just a background about ammonia, what ammonia is. What we're now going to look at is how we make ammonia. Okay, so the Haber process is a reversible reaction. This is that sign there. That sign means reversible reaction. Okay, so if you make too much ammonia, you can go back and make nitrogen and hydrogen. Okay, so that's what that little sign means. Normally we see this little arrow like that, but reversible reactions have the 2 arrows going each way. Okay, just means you can revert back to the product, the reactant, sorry. So there's the reactants, there's the products, and you can kind of revert back to them. Okay, nitrogen is extracted from the air, so there's loads of nitrogen in the air. Okay, it's the largest gas in the air. Okay, people often ask what's the point of it, because it's like 70-odd%, whereas oxygen's only 21%, and we know that we use oxygen to respire. So nitrogen is extracted from the air. Hydrogen is obtained from natural gases, so that means gases that you like pump out of the ground, stuff like crude oil, so it's from crude oil, are pumped through pipes. Okay, so nitrogen from the air, so we're over here, nitrogen from the air, hydrogen from natural gas, and they are pumped in to this machine, okay? Pumped into this machine. The next thing that happens is they enter something called a compressor, okay? So a compressor compresses, like the word means, compresses everything together, okay? So the pressure of the mixture of gases is increased so that they're more compact to 200 atmospheres of pressure. You need to remember that value. So what's the pressure of the Haber process? 200 atmospheres of pressure, okay? The pressurized gases are then heated, so around here, they are heated to 450 degrees. So 200 atmospheres of pressure, 450 degrees. It's really important that you remember these values. They're also passed through a tank containing an iron catalyst. Okay, so thinking back to year 10 rates, what does a catalyst do? A catalyst lowers activation energy. Okay, so it lowers the amount of energy required for a reaction to take place. So less energy for a reaction to take place. Okay. Another interesting thing about catalysts, which is why they're great in this kind of process, is that you can use them again. So that catalyst can be used to make the next batch of ammonia. Okay, so they're reusable. They lower the energy, so it means you need less heat. That's why 450, that might seem like quite a large number to you, but that's not as high as some reactions would be that we'll learn about. So that's why we've got that little bit of a lower temperature. I know it doesn't seem like a lower temperature, but it is, to be able to lower the temperature so that we can speed up the rate of reaction. Okay. The reaction mixture is then cooled, and so the ammonia liquefies. Okay, that just means that it's cooled down. It turns from a gas to a liquid. Okay, so it can be removed. The reason for that is a lot easier to remove a liquid from a situation than it is to remove a gas. So we cool the temperature down, then it liquefies and it can be removed. Any unreactive nitrogen, hydrogen then goes back to the beginning. So not all of the nitrogen and hydrogen will turn into ammonia. The chemical symbol for ammonia, like you can see at the top, is NH3. So nitrogen and hydrogen then be mixed together, okay, to make ammonia. Some of it isn't used, which is great about this process, is it's just recycled back to the top, okay? Remember, you can pause the screen if you want to make any notes. Just watch me do it again, okay? So, thinking about that now, what I want you to do, and I do want you to write this out because it's really important that you write it out, you've got these notes, and you think about what was the pressure that Miss Lahan said? What was the temperature Miss Lahan said? Why did we use a catalyst? Just thinking about it. Obviously, you can go back and watch that section again, but what I want you to do now, press pause and write this out, trying to fill in the blanks. Right, so let's go through the answers then. So what are the two raw materials you need, the two reactants? You need nitrogen and hydrogen. Okay, I'll pump through pipes. The pressure of the mixture of the gases is increased to 200 atmospheres of pressure. Okay, the pressurized gas is heated to 450. Okay, so remember I spoke about how you've got to remember them numbers. Pass through a tank containing an iron. Okay, so it's important you know what type of catalyst, an iron catalyst. Okay, the reaction mixture is then cooled so that ammonia can liquefy or turn into a liquid. I think that's how it's called, liquefy. Can be removed. Unreactive nitrogen and hydrogen are recycled. So like I said, this process, it thinks about that an awful lot, and it makes sure that if you don't use it all up, it can be used again. What is the purpose of the catalyst? We spoke about this. Speeds up reaction, lowers activation energy. Okay, why is the nitrogen and the hydrogen recycled? To higher yield, more product. If we can recycle it and start the process again, so we don't have to go find more nitrogen, extract it from the air, we don't have to get the hydrogen out of its natural gas. If we've just got them there, it means we've got more product, higher yield, which means we can make more money. Think about this as though it's a business, okay? We can make more money, and it's quicker. We're not extracting it from the air. We're not waiting around for that because we can just recycle it, push it back to the beginning, and start the process again, okay? So again, that's the answers to them questions. Finally, what I'd like you to do, okay, and I'll obviously put this PowerPoint up on Teams so you can fill it in or however you want to do it, or you can just answer on the sheet of paper. I want you to have a go at doing a little bit of research for me. So obviously we've talked about the Haber process, but the other thing that you need to know about, okay, is thinking about what a fertiliser is. All the answers to this will be on the internet. Disadvantages of fertilisers, describe what happens with fertilisers that end up in the river. So obviously I want to see review 1 and review 2 done, but I also want you to have a go at answering these questions. Okay, thank you.